Hi, today we're going to discuss how the derivatives affect the graph of a function. So the first thing we want to talk about is the increasing slash decreasing test. So we say that anytime f of x, f prime of x is positive on the interval from a to b, then we say that the function is increasing on that interval. When the first derivative is negative on a given interval from b to c, then we say that the function f is decreasing on that interval. Wherever the first derivative is 0, is when we have a horizontal tangent at that point. So that is decreasing and increasing test. For the first derivative test, basically it says this: if f prime is positive on AB and then negative on BC, so basically what happened is the first derivative is changing signs from positive to negative at this point x equals b. So then we say that f of b basically is a local maximum value. And when the first derivative is changing signs from negative to positive at x equals c, then the conclusion is that f of c is what we call a local minimum value. So this is what you call the first derivative test. And the point b and the c are called the critical points because the first derivative is a 0 there. Now we're going to do an example. So they give us the function f of x, which is a 3x to the fourth minus 4x cubed minus 12x squared plus 5. The first question is to find the interval of increase and decrease of f. And the second question will be to find the local maximum value and local minimum value of the function f. So going to the first question, when they ask us to find the interval of increase and decrease, so what we need basically is the critical points first. So step one, we need to find the critical points. To find the critical points, we have to set the first derivative equals 0 and then solve that equation for x. So here's the function f of x. We take its first derivative. We set that the first derivative equals 0. So we have this equation. And then we want to solve this equation for x. So as you can see, we can first divide this equation by 12. So after dividing it by 12, we get x cubed minus x squared minus 2x equals 0. And as you can see, we have x factor. We have x everywhere on every term. So we can factor out x to get x times quantity x squared minus x minus 2 equals 0. And then we set x equals 0 to get x equals 0. This is our first critical point. And this, the x squared minus x minus 2 can be factored as x plus quantity x plus 2 times quantity x minus 2. Since all of them are equals 0, we also have to set x plus 1 equals 0 to get x equals negative 1, and x minus 2 equals 0 to get x equals 2. So we have our three critical points. Now, the next step is to take those critical points and to put them on the number line. Okay, so we have a 0, negative 1, and a 2. So we follow the order of number line. So -1 first, and then a 0, and then a 2. So we plot those points there. On the top row, we put f prime of x. At the bottom row, we put the function f of x. So now we go back to the first derivative. Okay. So what happened is the zeros, so the critical points, we have 3 of them. So is dividing the number line into 4 sub-intervals, where one interval is from -infinity to -1, another one from -1 to 0, the next one is 0 to 2, and the last, the 2 to infinity. So we needed to pick a test point on every sub-interval. And we're going to test those points on the equation of f prime of x. Not f of x, but f prime of x. So that we know, we determine the sign of f prime of x. So if you pick a point -2, okay, so let's pick -2 on the first interval. Okay, so we take -2 into the first derivative test, the first derivative function. So if you plug in -2 here for x, you can plug this into here. So what you're going to get is this is going to be negative. So -2 times -2 plus 1 is negative, and -2 minus 2 is negative. So we're going to get negative times negative times negative, which give us negative. So basically we say that f prime is negative on the first interval. What does it mean in terms of the function? By the increase-decrease test, when f prime is negative, it means the function is decreasing. So this arrow mark shows that the function is decreasing. The function f of x is decreasing on the interval -infinity to infinity. Now, if you pick another test point between -1 and 0, like -0.5, into the first derivative function, you're going to get a positive number. I mean, you're going to have a positive number. So that means that the function is increasing on the interval -1 to 0. And then you go to the third interval, you pick a number between 0 and 2 somewhere, any number between 0 and 2, like x equals 1, into the first derivative function. You're going to get negative, because if you pick like 1, you get 2, and then this gives you -1, and that 1, so you get negative. So this gives you negative sign. So the f prime is negative here. That means in terms of the increase-decrease test, it means the function is decreasing on this interval. Last, you go and pick a 3 on the last interval. You get a positive first derivative function, which means the function is decreasing. So based on this table, we will determine where the local maximum and local minimum are. So we use the first derivative test to say that the first derivative is changing sign from negative to positive at these values of x. X equals -1. So that means that at x equals -1, we have a local minimum. So we can have f of -1 is a local minimum. And then we go to the second critical point, which is 0. We see that the first derivative function is changing sign from positive to negative at x equals 0. So that makes f of 0 to be local maximum. And again, we check the next. So here the first derivative is going from negative to positive at x equals 2. So we say f of 2 is basically a local minimum. Okay, so we state this here. So we say that there is a local minimum at x equals -1 and at x equals 2. there is a local maximum at x equals 0. Okay. So these are, now, if you want to find the local maximum and local minimum values, then you will have to evaluate the original function at those values of x equals -1, x equals 2, and x equals 0. So f of -1 is 0. Okay, so f of 2 is -27. Okay, so the local maximum value is f of 0, which is 5. Okay, and the local minimum values are f of -1, which is 0, and also f of 2, which is -27. So we solve all the questions that were asked us to do. Thank you.